So rational implies fractions, and rational expressions means fractions where the variables are found in the denominator. Specifically, they could be in the numerator, they just have to be in the denominator. So if that was a fraction, x is here to be a rational expression, whatever form it comes in. So they're going to just ease you into this pool of hot water. They're going to start with you just looking at what your expression's values can't be, because denominators can't be 0. Then they're going to have you simplify rational expressions. You know how to simplify a fraction, get out common factors and reduce. You can do that with polynomials. And then they're going to have you find least common denominator, because that's what two fractions need to add and subtract. So lesson 9.1 is adding and subtracting rational expressions. So lesson 9.2 is multiplying and dividing rational expressions, and 9.3 will be solving rational equations. We're looking only at 3. So it should be pretty like, this makes sense to me, I understand why we're going here, because I need to know how to add and subtract and multiply and divide before I can solve equations. So starting off the game, there are 19 questions, that's because there's so many parts to adding and subtracting fractions that aren't alike. Remember, the denominator has to be the same in order to play the add and subtract game with fractions. The same with add and subtracting rational expressions. And you guys' brains are more mature than when you first learned about fractions in 4th grade. So you've always either, challenge yourself to understand it, or you use technology to be able to do the math with fractions. But this technology can only help us so much. Got to be able to know when I had a rational expression where there's an x in the denominator, there's some things that x cannot be. So for number 1, they're asking you what the excluded values are. Now the numerator can be 0, but the denominator can't be. So to find that, you must factor first. Factors of 6 when subtracted give me 1. And this is where I find my excluded values. X cannot equal -3. If I put a 3 in there, I'm not going to get 0. It's what makes the zeros, the denominator 0. So this is the zeros of the denominator. And you did that in module 8. You found the asymptotes that made the denominator 0, the vertical asymptotes. You found the domain. Remember, the domain could be everything but these values. The other one is x cannot equal 2. So you've done this before. So that should be like, yay, I get this. I know how to do this. I factor the denominator, and then whatever makes those either 1, 0 is the answering the question. So in the big picture, when you're that executive on the board that need to solve a problem, and one of your answers is a 0 of the denominator, you say, wait a minute, this is impossible. Let's go back to the drawing board. So that's, why you need to know this truth. So the first several of them, first couple, 1 and 2, are just asking you to find excluded values. Number 2 on my example was already factored, so that was kind of nice. So all I had to do was look down here and say x cannot equal 0. Remember, that's what an x factor gets. Or x cannot equal a negative 14. So for number 2, it is drag and drop. So they've got some distractors there for you. But if you know the truth, they can't fool you. So looking at the assessment that I can provide for you down the road, this will be one of the, be able to tell me the excluded values. So that's what I would ask you. That's these problems. Okay, number 3 says the word simplify. And in fraction land, that means reduce. But in rational expression land, we can't reduce until we factor. So this means factor and reduce. In fraction land, you did that in your head. You know, if you saw 3/6, you just automatically reduced it to 1/2. You didn't say, oh, they both have a common factor of 3, so I need to factor 6 into 2 times 3, and then cancel the 3's, and then that leaves 1 in the numerator and 2 in the denominator. No. You just go there and do the mental math, and you're done. This one's not so simple because we have unknown values. Called x, makes things a little messier. Now my software have parentheses around here. I have no idea why they did that, whatever. Anyway, technically they don't have to be there. They have it though in my software, you know, on my, see my example? So that doesn't mean you have parentheses in your answer, okay, friends? So we just need to factor the numerator. We factor them both now. So I can cancel if there's a common factor. Can't cancel unless it's a multiplier. I see a -7 staring at me. So I factor out the -7. Just notice that. You know, that's kind of gives you a hint what to take out. This guy's factors of 6. When subtracted, give me 5. Now, 2 and 3 add up to 5, but they don't take a difference of 5. So don't let that fool you. X minus 6 times x plus 1. Now I need a -5. See why it's a -6 and a +1. Think that through. Think through. Now here, this is a commutative property of addition. You can add numbers in either order. So technically, these are the same number. Therefore, I can cancel that common factor, and my final result is when you put this in the software, you know, you got to make a fraction first. Then put your -7 in numerator and x minus 6 in denominator. No parentheses necessary. Am I melting here? Go. For number 3 in the answer, okay? The whole fraction. So if you're factoring theme, you will like this assignment. Lots of factoring. If you're weak, here's your time to practice. Don't just skip it. Factoring, factoring, factoring. Factoring, factoring forever. Practice, practice, practice. You're going to get better at it if you just give your brain a chance to understand the parts. It's like a recipe. Okay, number 4 is the simplify. So I'm just going to go on and put my expression. And I know my rule is to factor and reduce. Both have a -1. Okay, factors of 40 when added give me 13. Everything's plus. Okay. So 8 plus 5 is 13. 8 times 5 is 40. I see a common factor. You cannot cancel unless they're being multiplied. So in your software, you hit the fraction button and then enter numerator over denominator. That was fun. Fun, fun. I like factoring. I like canceling. Here we go. I like rational expressions. They're just fun. Give me a challenge. They'll always give us a challenge. Just a few examples. Anything is possible when you're factoring. Remember, if there weren't any common factors, you're done. But we're in the land of Oz. You're practicing canceling, and so that's why they've given us polynomials with common factors. Set us up for success. Okie dokie. Five is a fun one. I need a new page. It's going to take a little bit because it's factoring game where there's a coefficient in front. Remember, you can't cancel anything until you factor. So it looks like we have to use the bottoms up method to factor. So I take my 12x squared plus 8x plus 1, and then I pretend it's x squared plus 8x plus 12. And I have to come up with factors of 12 would add to give me 8. Well, 1 and 12 don't add up. 2 and 6 do. 3 and 4 don't. So it's factors of x plus 2 and x plus 6. So be careful. You know, got to make sure you're telling the truth there. Then you get to, don't forget to take the pretend back to real again. I'm going to divide back my 12, reduce my fractions, and so my numerator is going to be 6x plus 1 times 2x plus 1. So I'll write that. Numerator, 6x plus 1 times 2x plus 1. That's my numerator factor. Okay, my denominator story, 2x squared plus 3x plus 1. Pretend it is x squared plus 3x plus 2. So I need, 2 only has 2 factors and everything's positive. 2 and 1, yay. Then I got to divide back the 2. Reduce and move the denominator next to the x. So my denominator then is x plus 1 times 2x plus 1, which is nice in this land of Oz. We just need to cancel like factors and rewrite it as a fraction without parentheses because nothing's being multiplied to those binomials. So you don't need parentheses. Doesn't like extra information in the answers. So that was fun. Factoring. I love bottoms up. It's so clear. Just move it over, factor like you can, move it back. Yes. They're giving you a little taste of all kinds of factorings. You know, anything's possible. Thankfully, they don't have any cubes in here yet. You might before we're done, but for now, I just have to factor the difference of squares. And look at here. What a nice coincidence. X to the fourth is a perfect square. So I can cancel those like factors. And I looked it up in the homework to see what they wanted. If they wanted x squared minus 1 or they wanted that factored. And they showed their final answer as factored, so hopefully I'm not leading you astray. We really need, when you're working with expressions, keeping factors, yeah, that's a big deal. You know what I mean? Like you want to keep the factors. Because if you're combining like terms and stuff like that, then you might get to factor some more and cancel some more and reduce some more. So that's why they always like the answers in factored form till the very end. And then in this case, they wanted you to still factor more. Now yours might be an x squared minus 7. Well, obviously then you can't factor that. Or an x squared minus 6. Or an x squared minus 2. So, you know, I only went on because I could. You know, if your example has a number there that's not a perfect square, stop. But if you do have an x squared minus 4 or whatever, you just go ahead and keep factoring on number 6. Okay, those are the, we had 1 and 2 for excluded values. 3, 4, 5, and 6 will give you a chance to simplify expressions. Number 7, now we're getting into the nitty-gritty of being able to add or subtract rational expressions. They need a least common denominator. That's your goal. And it said in the instructions, find the least common denominator for the rational expressions. Enter your answer in factored form. In other words, you gather together like this might be an LCD. Don't multiply it back out again. Just leave it as it is. So what are you talking about, Fisher? You notice we always look at the original denominators. We factor those. Factor this one. And then I need what's in common to either one or both as my LCD. Because these two are different numbers, I can multiply those. I can multiply 3 times 4. Don't leave that in factored form. So for your numbers, you put the what they multiply to. Now, if they had common factors, let's say that was 6 and 4, that would still be 12 because 6 goes into 12 and 4 goes into 12. So got to watch out. Don't just multiply and make sure it's the least common multiple of the 3 and the 4. Then I need an x plus 9 because that's what's in that denominator, and I need x minus 8 because that's what's that denominator. And this is what they mean leaving in factor form. The polynomial parts, okay? Numbers, go ahead and multiply with the polynomial parts. Leave in factored form. That's a good. I don't know if he's dried out or if he's totally toast. Give him one more chance. So now we've got several of these because, you know, there's so many ways you can figure out what the LCD is. You just never know. I think we go through number 12 to do LCDs. We'll be over halfway. You only have the last 13, 14, 15, 16, 17, 18, 19, 7 problems that you will be adding or subtracting. Okie dokie. Last 7 problems. All right, number 8. LCD of these two fractions. Factor the denominators. Multiply, you know, 11 and 7 don't have anything in common, so it's just 11 times 7. And then since this shows up in both, I only have to write it once. Because it shows up once here and once here, so in common, I just need it once. For number 8. Any comments about that onceness? If I divided these two, I'd get the answer of 7. If I divided these two, I'd get the answer of 11. You know, that's the point. That's what a least common denominator is. Common multiple of both, but it's the smallest one. I mean, life's hard enough. Besides, getting too big of a denominator, making yourself miserable that way. That's plus 10 and 5x plus 15 over 10x plus 20. So this is the next step in being able to add these two fractions together, is finding the least common denominator. So this is, you know, this is a powerful piece of the puzzle. So I factor x plus 2 times x plus 5. This guy has a factor of 10 and x plus 2. And gather the like factors. This one has a 10. They both have an x plus 2, so we'll only write it once, and an x plus 5. So I said gather the like factors. Gather all the factors and only write the ones that are alike once. So if this guy had another x plus 2, I'd have to write it twice in the LCD. So hopefully now you know why I gave you so many, because I need you to practice factoring and finding the LCD. And I did not highlight those. I am so sorry. Hope that makes a lick of difference in your brain. Here's that, what you'd enter into the software for 8 and 9 in factored form. Squeeze in one more for the good of the cause. Now 11's got a different story, so we will start there tomorrow. I want this to be painless as possible. Now in my software they had a -1x, so whatever that's about. Yeah, it's another one of those. That doesn't have to be there. Why are you putting it there? But I won't complain. Factors of 32 and subtract to give me 4, 8, and 4. Needed to be in the larger factor gets a negative sign, just like that. Factors of 20 when subtract to give me 1, 5, and 4. 5's a larger one. Write it down. LCD. X minus 8, x plus 4 only once, and x minus 5. And you're done over halfway through the homework. Please ask questions along the way. Factor, factor, factor. Factor, factor, factor. Factor and find. Here we go. So tell your younger self and your younger peers that haven't been through this game yet, learn how to factor. Don't give up until you know how to factor.